Hi, myself N. Praveen Kumar, working as assistant professor in mathematics. Welcome to numerical methods and integral transform course. In this lecture, we are going to be discuss about interpolation and its real-time applications. So, introduction of interpolation we are going to be see in this lecture, and application of interpolation we are going to be discuss. So, see the definition. Interpolation is a process of determining the unknown values. So, the unknown values that lies between the known data points. If you see the data points, so the set of data points x and y, where x is values, the independent values, or you can also call it as input values, where the y values are output values or functional values, or you can also call it as experimental values. So, in this, if you want to be find any value between these, let us assume if you want to be find y value or experimental value when x is equal to 0.5. Look at here where the suffixes are 0 and 1. So, you want to be find the experimental value when x is equal to 0.5. So, which lies inside, and these all known values, we are finding the unknown value which determining the unknown value. What is that unknown value? Where the unknown value is y of 0.5. So, this we are finding using of this process. So, this process is called interpolation is a process. So, this is one of the usage and definition of this interpolation. Similar way, interpolation can be used to estimate the, so important point here, missing values. So, missing values in the data set to make predictions for the new data based on the known data. So, if you have some known data where you have some data points x and y similar way, so you have some data points 0, 10, 15. So, where that experimental values or function values have something 4.32, something 7.31, 9.81. So, we want to be know or else this point is missing, where earlier you know the value is fine, but where this value is missing. So, this missing value we are going to be find using of this interpolation concept. So, the interpolation is one of the uses to find out the missing values. So, this is what the second usage of the interpolation. Similar way, interpolation is a fitting of smooth curve. So, fitting of a smooth curve through the given set of data points. So, generally we just assume the graph or we find out that function. So, same way you have some set of data points. So, where the set of data points you have, so some 0 to some I have some points 3 to 4 set of data points where the function value is something like. So, now I need to be estimate y when x is equal to 9. Similar way, x is equal to 12 I require, x is equal to 40, you require lot of points. So, each and every point you cannot find. So, you try to be find out each and every point, it will be take a lot of time. So, lot of time and time waste process. So, then the time we construct, so a smooth curve. So, once you construct a smooth curve, so y is equal to in terms of some x. So, then you can able to find n number of points at a time. Substitute x is equal to 9. So, you will get some y value. Similar way, substitute x is equal to 12. So, like you can substitute n number of points to find out that particular value. So, this is the reason why we are going to be fit a smooth curve, right? That is what one of the usage. Where, so if you see the different names of this interpolation is interpolate, can also be called as inset, interculate, interject, interpose and introduce, like many different names we are going to be used in the different areas. So, these are the introduction about the interpolation. So, then we are going to be discuss about few interesting applications. So, first one is video interpolation. So, video interpolation is, so there is some starting frame is provided and ending frame is provided. So now we are going to be estimate, so using of the interpolation, how a human can speculate or imagine several possible frames. So how this higher jump person to get over the bar. So look at that, there is two kind of the possible frames which is provided using of the interpolation. So possible frames. So starting he is jump something. So later how he is going to be jump the bar. It let us take the 0 seconds. It may be taking 10 seconds or 12 seconds. It will take some time. So in between this, so they are going to be estimate. So how much the time will take? It will take 2 seconds, maybe 4 seconds, maybe 8 seconds, like this. So a task of interpolation given a starting frame. So starting frame is provided and end frame. So end frame is also provided. So we are going to speculate the several possible frames between these. So here it is showing like possible ways. So how a jumper jumping over the rod. So these possible frames we are going to be estimate, speculate and predict using of this interpolation concept. So this is what one of the best application in the interpolation. So see the second application, zooming digital images using interpolation techniques. Look at, so basically the original image is located here. So zooming using of the mobiles, so it will have very low resolutions. So in the process of low resolution digital images, you can try to be resolution and zooming n times, but you cannot able to see that properly. So it is very challenging problem. So it is very challenging problem, so that these errors, so quantitization and taking of many different kind of the samples, in particularly zooming of such images is very much complicated. The zooming process can be done resampling and normally and constructing the distributions and employing. So still you cannot give much like a clear image. So that this interpolation technique, using of this interpolation technique, we use this interpolation functions zooming low resolution images. Look at, so in the circle it is clearly mentioned where original image is this, but you zoom it n number of times, you cannot able to see, but after applying the interpolation you just look at, so the image is somewhat is improved, we can able to identify the images very clearly. So that is what the usage and application of this particular interpolation concept. So this is one of the application. Now we will see the another application. So predict the motion differences using interpolation. So look at these are the original image, where the original image is starting point something like here. So end. So just if I consider a frame, so this is what the starting image, in that frame this is the end image. So the elapsed time, if you see, 1/60 seconds. This is what the elapsed time. So in between the middle one intermittent image is missing. So this from here to here there is a space, we need to be estimate the image how it moves. So that is what we are going to be predict. So predict the motion differences. So moving how it moves from, so this first frame to the end frame. So we are going to be predict and generate the interpolate images. So which means just filling the gaps. So nothing else, just filling the gaps. So for that, allowing us, we try to be construct a smoother video to see that properly. So just we are going to be estimate the image of this. So that's what. So the combining of these, so we are interpolating of these images. So the elapsed time just we may increase, may decrease. So according to that, we are going to be find out. This is what the starting image, where we identified and we constructed, we predicted a new image, later this end frame value. So this is what one of the application using of the interpolation. So predict the motion. So like using of this many kind of applications now it is introduced in the market. So that usually you can call it as smooth video project. So the same frame interpolation technique as available high-end TVs. So now in the market so many like TVs are available, slow motion pictures and 1.5 times of zoomer and 1.5 times of moving, and these kind of so many, even projectors also so many advanced projectors are available. So these all related to motion flow, how it is, either you want to be move slowly or 1 point times faster, 2.5 times faster, or else you want to see more clearly, so just we reduce the speed. So this is what the newest technology, NVIDIA DLSS3 is another example of this particular technology. So what this technology is, basically it increases frame rate by generating intermediate frames. That is what we are going to do, the starting frame and ending frame. So intermediate frame, we are trying to be identify and construct the image more accurately between the existing ones. So where this is the existing one and this is, so middle one is not existing, we are predicting that. So that is what, so between these existing ones, in order to produce very smooth, so smooth, fluid and clear motion. So this kind of the technology, and which we are going to be implement using of the interpolation concept. So now where the interpolation is one more application, interpolation by convolution. So this is one of the application where, so interpolation by convolution. So there are two images which I have provided, a two-step approach. First estimate the motion. So how it is estimating from one frame to another frame, the motion. So using of this motion, interpolate. So now the interpolation concept is introduced. So using the pixel color based on the motion. So how it is moving based on the motion, we are going to be estimating the pixel color by this interpolation. So this interpolation by motion estimation by color interpretation using of the interpolation concept. The second one is also similar. Our method directly estimates. So this one of the convolution kernel is a medium transfer. So that convolution medium transfer, it uses the convolve two frames. So this is one of the frame and this is one of the frame. So this is the convolution kernel. So this kernel is called convolution kernel. So this convolution kernel and uses to convolve two frames, and using of this we can interpolate the pixel color. So like many other process is there. So applying using of the signal spectrum. So spectrum of the signal we are going to be estimate using of this interpolation. So look at here. So spectrum is a original signal. So we are interpolating by factor 2. So therefore this is what the original one. So using of the factor 2 we are identifying some image here. So using of the factor 3 we are identifying the two images here, and using the factorial we are identifying like the images. So this is what it is having, the interpolation concept is involved. So like the two more applications in the medical field. So ZIP is very much important application. So it is substitution of zeros. So if you are unable to unmeasure or you are unable to measure the data points, so just you fill with zeros. So fill with zeros, increase the size of the matrix. So data pair. So basically there is a application of Fourier transform. Before applying the Fourier transform, we must be apply zero filling interpolation. So where the data is unable to measure it, so you can fill it with zero. So later just you apply the transformation. So actual resolution, then it is going to be happen. So look at here, minus 15 degrees and 0 degrees and plus 15 degrees. Adding of all this, just we are going to be constructing the frame. This is what we can call it as 2D frame interpolated CD image. So this is what one of the application. So the last application which I am going to be discussing this interpolation in MRI. So in MRI there is a tumor is there in the pancreas. So this tumor estimating we are going to be using of this particular interpolation concept. So there is two planes, coronal plane and lateral plane. So coronal plane is, so it divides the body from side to side. So side to side, that's what the coronal plane, side to side it is doing. Where this lateral plane, front and back, look at the front and back, using of this concept we trying to be estimating the this tumor and its size, so that we can simulate the injected point. If you estimate that size of this tumor, so we can simulate and injected a point using of interpolation MRI. So this is also one of the application. So many applications are there. In this session we discussed the introduction to interpolation and real-time applications. In the next session we are going to be discuss about interpolating the values based on the locating points. Thank you.